Now, let's try to look at a numerical which will help us in computing the moments of some miscellaneous distribution for which we have the probability density function. So, for example, look at this. There is a probability density function that is given f of x equal to 1 by theta times e to the power of minus of x minus beta by theta, where x is greater than beta. So obviously we know that the integration of this, again, because the sum of probabilities should be 1, integrating this across from beta to infinite. If I am integrating 1 by theta times e to the power of minus of x minus beta by theta, if I am integrating it over all the x, it will be equal to 1 because the area underneath the curve should be equal to 1. In other words, probably when I am assuming that x minus beta equal to y, right, dx equal to dy, and if I am just changing the limits, okay, by substituting beta minus beta, so this will be a 0. Infinity minus beta is still infinite, but in terms of 1 by theta, yes, this is 1 by theta e to the power of minus of x minus beta is y by theta. So anything that comes 0 to infinite, 1 by theta times e to the power of minus y by theta. If I am getting something of this form, dy, this will definitely be equal to 1. We'll use this result at a slightly later point in time. 1 by theta times e to the power of minus y by theta dy should be equal to 1. Now, determine expected value of x. Now, what is that I do when I have to find out the expected value of x? I integrate it across the same, right, x times the f of x. So I am taking x by theta e to the power of minus of x minus beta by theta dx. Now I will do the same transformation, x minus beta equal to y. So which means this would be from 0 to infinite. X will be y plus beta then. Okay, y plus beta by theta e to the power of minus y by theta dy. So let me split this across. Integral 0 to infinite y by theta e to the power of minus y by theta dy plus integral 0 to infinite beta times 1 by theta e to the power of minus y by theta dy. Now I can use this result for the second term, integral 0 to infinite 1 by theta e to the power of minus y by theta. This is equal to 1, which means this term is only beta. Now this part I have to integrate 0 to infinite y by theta e to the power of minus y by theta dy, right? Integral 0 to infinite y by theta e to the power of minus y by theta dy. Now 1 by theta I will take out at least because it's a constant. Now I'll do the integration by parts. So the first one I'll take it as it is, and for the second term I'll do the integration, which is e to the power of minus y by theta divided by minus 1 by theta minus integral of, I'll take the derivative of the first one, which is 1, and I'll do the integral of the second one, which is minus y by theta by minus 1 by theta dy. This is what we do in integration by parts, just a step by step workout without missing. Okay, the first part is minus theta y e to the power of minus y by theta, and the second one will become theta times integral of e to the power of minus y by theta dy. Let it be step by step, otherwise something will go off. 1 by theta times minus theta y e to the power of minus y by theta plus theta times e to the power of minus y by theta by minus 1 by theta. This is the entire integral now. Integral wise we are comfortable, we are done. Minus theta y e to the power of minus y by theta minus theta squared times e to the power of minus y by theta. This entire thing is integrated between infinite and 0. So when I am integrating it to infinite, this part is nothing. But when I am doing it with 0, so this part is nothing again. So minus of this will come out as theta squared times e to the power of 0, 1. So minus of minus theta squared is coming out here, which is becoming plus. So overall this is becoming theta. So integral of 1 by theta, y by theta e to the power of minus y by theta dy is becoming theta. And the second term which we have got, beta times integral 1 by theta e to the power of minus y by theta, it came out to 1. Which means the overall, the expected value of x in this whole case is coming out to theta plus beta. Okay, the expected value of x is theta plus beta. Fair enough. Now I am supposed to find out the expected value of x squared. I'll do the same workout. Integral 0 or beta to infinite. So for x squared it becomes x squared times f of x. X squared by theta e to the power of minus x minus beta by theta dx. Now again I'll say x minus beta is equal to y. So I have dx equal to dy. Now this integral, this beta minus beta, so this becomes integral from 0 to infinite. X will become y plus beta. So y plus beta whole squared by theta e to the power of minus y by theta dy. Now even the same, I'll take it as y squared by theta. I'm splitting it up. Integral y squared by theta e to the power of minus y by theta dy plus 2 beta y by theta, right, the integral of 2 beta y by theta e to the power of minus y by theta dy plus beta squared by theta integral e to the power of minus y by theta dy. Now if we remember, okay, let me take this as 1 by theta inside. Now this integration between 0 to infinite, we have got it as 1 already. 1 by theta times e to the power of minus y by theta dy. So this term I know it is b squared, beta squared. Now this also, if I take out 2 beta by theta, right, or probably 2 beta if I am taking out, right, if I am taking out 2 beta and I am integrating y by theta e to the power of minus y by theta dy, this was nothing but the mean kind of stuff which we have got, which we got as theta. So this becomes 2 beta theta. Right, this entire thing was worked out as theta for us earlier. So I'll use that result without solving. So this becomes 2 beta theta. So 2 beta theta is there plus beta square is there. Now what about the first one? Integral y squared by theta e to the power of minus y by theta dy. Integral y squared by theta e to the power of minus y by theta dy. Now the same logic, I'll take 1 by theta out. The first term times the integral of the second term minus integration of derivative of the first term times the integral of the second term. When you are doing it by parts, you just be careful doing it step by step. That's it. 1 by theta times, this becomes minus theta y squared e power minus y by theta. And okay, this becomes 2 theta times integral y e power minus y by theta dy. Yes, this is what is coming out. 2 theta times integral of y e power minus y by theta dy. Now what I can do is numerator and denominator I'll multiply it by theta so that I get something of this form, and I know that this is nothing but the integral of this entire thing is nothing but theta, which we have got earlier. The integral of this entire thing is nothing but theta. So this is very much working out as 1 by theta times minus theta y squared e to the power of minus y by theta plus 2 theta squared times theta. So it becomes 2 theta cube. Right? This becomes 2 theta cube, which is integrated between infinite and 0. So it becomes 1 by theta times. Okay, so infinite substitution, nothing is going to be there. And 0 when I am substituting, it is, in this we have already done the substitution, only do it here. So infinite and 0 substitution here is not working out anything, so it is left with 2 theta cube, which is resulting in 2 theta squared. So the first term is 2 theta squared, the second term is 2 beta theta, and the third one is beta squared. So this is what will come out to be our expected value of x squared. So expected value of x squared is coming out to be this. Expected value of x is coming out to theta plus beta. Now from here I can find the variance, which is nothing but expected value of x squared minus expected value of x whole squared. Theta squared plus beta squared plus 2 theta beta. Now this is going off, and all I am getting, even this beta squared is going off. 2 theta squared minus theta squared, which is coming out to theta squared, which means the standard deviation of x is the square root of the variance, giving me as theta. So I am able to show that the standard deviation of x for this example is theta. Fair enough. Now, a sample of 50 values is given such that sigma xi is 8200. So the sum is 8200, which means I can very well find out the mean. Sigma xi is 8200, which means mean is 8200 by 50, which is giving me 164. And I know mean is nothing but theta plus beta. Theta plus beta is 164, and sigma xi squared is 2 million. Sigma xi squared is 2 million. So again I can find out expected value of xi squared from here. Expected value of x squared for me is 2 million divided by 50, which is giving me 40,000. So expected value of x squared is 40,000, which is nothing but 2 theta squared plus beta squared plus 2 theta beta is equal to 40,000. And we have got theta plus beta equal to 164. Probably I can write this as theta squared plus beta squared plus 2 theta beta is nothing but theta plus beta whole squared is equal to 40,000. Now from here I get theta squared plus theta plus beta is 164. 164 squared equal to 40,000. Now from here I can find out my theta squared, which is 40,000 minus 164 squared, and probably from there I can even compute theta also, which is the square root of 40,000 minus 164 squared gives me that the theta is around 114.47, and from there I know theta plus beta is 164. So from here I get my beta as 164 minus theta, giving me 49.52. So that's the way out. If at all any miscellaneous distribution is given and I'm supposed to find out the mean and the variance and any other moments, this is the typical process that we are following for the same. Right?